A CPU architecture refers to how Intel arranges all the different components on the actual CPU and how they work together. What you see here on the right hand side is a Nehalem CPU, while this image here on the left hand side is a 6-core Sandy Bridge CPU. And you can see straight away that the two architectures are quite different from each other, even though they have the same number of cores. For example, in the Sandy Bridge architecture, all the cores are situated around the cache. The cache is the short-term data storage area for the CPU, while in the Nehalem architecture, the cores are evenly distributed between the two caches, and there are many other details on how the two architectures process data differently. Intel refreshes its CPU architecture every 2 years or so, and it does this to increase both the processing power of a CPU as well as its energy efficiency. Nehalem came out in November 2008, and Sandy Bridge came out in January 2011. This chart shows the time taken for different CPUs to transcode the same file from MPEG-2 format to QuickTime H.264 format. You can see that for two CPUs that have an identical number of cores and frequency, as we have here in bars 3 and 5, the Sandy Bridge CPU is about 15% faster than the Nehalem CPU. The 32 nanometers and 45 nanometers that you see by each CPU description refers to the actual size of the transistors in each CPU. Just to give you some idea of how large 32 nanometers is, the average human hair is 6,000 nanometers in diameter, or 200 times larger than the transistors in these CPUs. So we are talking about objects at the microscopic level. You can see that as the architecture gets newer, as we go from Nehalem to Sandy Bridge, the size of the transistors goes down. This is because the smaller the transistor, the less power it consumes, and the more transistors I can fit in a given space, so the greater the processing power of that CPU.